Hello everyone, this is Manohar Reddy, Department of Cybersecurity, Institute of Aeronautical Engineering. Today I am going to discuss about the next concept in the database management system is view of data. View of data, that is also called as levels of abstraction. Levels of abstraction. So in the previous sessions we already discussed about the database management system, architectural components, database management system, client server architecture, and database management system types and everything, right? So today we are going to see the concept of how the data is hidden, how the data is structured, how the data is organized in the different levels, so the concept name is what? A view of data is also called as the levels of abstraction. So a database is nothing but it's a collection of interrelated data and set of programs that allows users to access and modify the data. So users has to write some data and the user has to access the data and users has to modify the data. So that's why we can say that a database is a collection of interrelated data and a set of all the programs that allows to users to access it and modify the data. If he wants to modify the depending upon the updates, he wants to modify, then he can modify. He wants to access the data, he can access directly the data. And a major purpose of database system is to provide users with an abstraction of view of the data. The major purpose of the database is to improve abstraction of the data, abstraction of the data. That is, the system hides certain details of how the data is to be stored and how the data is to be maintained. How the data is to be stored and how the data is to be maintained. That is the main purpose of the database, to do not show complete details of database. So that is nothing but abstraction. So database abstraction is nothing but it hides the data, unnecessarily data. It hides the structure of the data. It hides the location of the data where it has been stored. So the coming definition is what data abstraction is. Its system hides certain details of how the data are stored. It hides the details of how the data is to be stored and maintained is called as what? A data abstraction. Is called as what? Data abstraction. So the main purpose is to maintain and accessing the data which is hidden and which is going to be maintained to be hidden. So to hide that all the data, it follows three levels of abstraction. So to hiding the data, we have to know about three levels of data. So that three levels are nothing but one is physical level or internal schema. We already said that it is levels of abstraction as well as view of data. So view of data is nothing but what we can see on the screen, what we can hide on the screen. So levels of the screen. So levels of the data is nothing but in what level we are going to see the data, in what level we are going to hide the data, in what level we are going to shows the structure of the data, and where we can locate the data, where we can have to see that location of the data. So this is all nothing but levels of the data. So that's why we can say that view of data as well as levels of abstraction. So first one is what? A physical level or internal schema. And second one is what? Conceptual level or a logical schema. Conceptual level or logical schema. And the third one is what? View level or external schema. So this is conceptual level or logical schema. And third one is what? View level or external schema. So internal schema is nothing but it is internally it will be added, and logical schema is nothing but it is logically added in between the internal and the external. And the view level or external schema, it is added in the external point of view, what we can see on the screen directly. So that is nothing but external schema. So we will look at this all the levels, how they are going to be stored and how they are going to be modified. So see here, view of data, and this is the first level, view level or external schema. And second one is logical level or conceptual schema. and this is what internal schema on physical level. So this is nothing but view level or external schema. We already said that external schema. So external schema, so what we are going to see on the screen directly, we are writing some command, we are creating some database, we are creating some tables, and we are displaying some query results as well as. So what we are seeing on the screen is completely view level or external schema. We know that we already having the data, and we are going to see on the screen. So that is nothing but we are accessing the data, and if we want to modify, we can do that modifications also. So that is nothing but external schema or view level. External schema or view level. So in this level we can directly access the data, and we can modify the data also. We can modify the data also. And second one, conceptual level or logical level. Conceptual level or logical level. So conceptual level or logical schema, this is nothing but a secondary level. So here the data, how the data is to be stored, how the data is to be stored, and what we can create the structure, how we can create the structure to store the data. And third one is internal schema or physical level. Internal schema or physical level. So where the location of the data is to be stored, exactly where the location is to be stored, the data is to be stored at particular location of the data. So these three are the levels of abstraction. Levels of abstraction are view of the data. So one is view level, and second one is logical level, and third one is physical level. So view level is also called as external schema. Logical level is also called as conceptual schema, and the internal physical level is also called as internal schema. We will see each one by one. So first one is what view level or external schema. So this level tells that application about how the data should be shown to the user. How the data should be shown to the user. So how user is going to see the data, and how user is going to be modify the data. So that is all completely you can see on the screen directly. You can see on the screen directly. So you can access the data directly, and if you can modify, if you want to modify, you can modify the data directly. So example, if we have a login ID and password in a university system, university or college system, if we have any login ID or password, so then as a student can able to see the marks, see the attendance, and see the fee structure of all these things. But the faculty of the university will have a different view. The faculty of the university will have a different view. The student can have the marks, he can able to see the marks, he can able to see the attendance, and he can able to see the fee structure also. But the faculty of the university will have a different view. The different view, he will have the options like salary options, edit marks options, edit marks of a student option, enter attendance of the students also, etc. So both the student and the faculty have a different views. They can see the view, they can see the view level or external level on the screen. But depending upon their view, depending upon the view of the point, they can able to, faculty can able to edit the marks, faculty can able to edit the attendance also. But student can not able to edit the marks, and student cannot able to edit the attendance. He can able to see the marks and attendance only. He cannot able to modify them. He cannot able to modify them. So that's why we can say that these two have a different views. These two have a different views. So by doing so, the security of the system also increases. So we are maintaining a separate levels of view for the user as well as faculty. So that means indirectly we are providing some security of the system is to be increasing. So in this example, the student can't edit these marks, but the faculty who is authorized to edit the marks can edit the student's marks also. So the dean of the college or university will have some more authorization. The dean of the university have some more authorization accordingly. So he will has his view. So dean has another view, faculty has another view, and student has also another view. So the more authorization people can have a more different view, more different view. So different users will have a different view according to the authorization they have. So different people, different users can have a different view level depending upon their authorization levels, their authorization they have. So that's what we are going to see on the screen. So view level is completely what we are seeing on the screen, what we are going to accessing on the screen. So those we cannot edit itself because of the authorization privilegation. So student has to only see the marks as well as attendance, but faculty can edit the marks as well as attendance. And dean of the colleges or dean of the universities have some more advantages, some more authorizations. So they have uh, some more purposes to edit the marks or edit the attendance and everything. So they can have some more privileges to do something, right? So this is what we have seen on the screen, right? And this is view level or external level. And second one is what conceptual level or logical level. So conceptual level or logical level. Logical level, the name itself, the data, how the data is to be stored. So this level tells that how the data is actually stored and structured. So what we are seeing on the screen, the tables are databases are everything. So how they are stored and how they are structured actually. So this level tells that how the data is actually stored and how the data is actually stored structured. So for this purpose, we have a different models. We have a different models by which we can store the data. We have a different models by which we have to store the data. So example, let us take an example where we use the relational model for storing the data. We can use the different keys, different relations to store the data. So we have to store the data of a student. The columns in the student table will be a student name, student age, student mail ID, and student roll number, etc. So these are the columns of the student table or student database, whatever it may. We have to define all these at this level while we are creating a database. We have to define this all the fields, student name and age and mail ID and roll number and everything. Uh, we have to define this all the things at this level. So for creating the through the data is stored on the database, but the structure of the table like student table, teacher table, books table, it is defined here the conceptual level or logical level. So by mentioning this all the fields, the student name, age, mail ID, roll number, and everything, the table is going to be created and stored in particular place. Created and stored a particular place. Similarly, for the faculty or for teacher table contains a teacher name, teacher ID, and teacher salary like that. And similarly, books table, book ID, book number, book author. So like the way different fields can have the different structure of the tables. So this is what we have to understand from this conceptual level or logical level. So also how the tables are related to each other are defined here. So a student can contain a relation with the teacher. A teacher contain a relation with the books. So like the way each and every table can have a relationship with another table. Each and every table can have the relationship with another table. So this is what we understand from this conceptual level. So how the data is to be stored, how the data is to be stored, and how the data is to be structured actually. So how it is structured in the inside of the view level, that is nothing but secondary level conceptual level. So here from this we can say that we are creating a blueprint of the data at the conceptual level. Just we are creating a blueprint, a model of the data. So a Xerox, like a Xerox copy of the data. So exactly what we are stored and how the data is to be stored. That is what we understand from this conceptual level or logical level, right? The next, physical level or internal schema. Physical level or internal schema. So as the name suggests, the physical level tells us that where the data is actually stored. So external schema or a view level is nothing but what we are seeing on the screen. So that is external level. And conceptual level or logical level, how the data is to be stored and how the data is to be structured. But in the physical level or internal schema level, where the data is to be stored actually. So the location of the data. location of the data where it is stored. So that it tells that actual location of the data that is being stored by the user. That is being stored by the user. So the database administrator DBA, we can say that database administrator decide that which data should be kept at which particular disk drive, which data should be kept at which particular disk drive. So where he wants to store the location, where he wants to store the data actually, and how the data has to be fragmented and where it has to be stored actually. So they decide if the data has to be centralized or distributed. So depending upon the data centralized or distributed, they can able to store on particular location. So though we see that data in the form of tables at view level, the data here is actually stored in the form of files only. So whatever it may be, whatever the data is to be stored in the database is going to be stored in like a tables as well as it's like in the form of files, so it is completely designed and developed by database administrator. It is completely designed and developed by database administrator. So he decides that where exactly located, where the data is to be exactly located, and where the data is to be exactly stored. So it's completely depending upon the database administrator. So how or she manages the database at the physical level. So data abstraction provides us with a different view and help in achieving the data independence. So why we are doing all these levels in the sense to achieve the data independence. So we don't want to maintain a data duplications or data redundancy. So for this purpose, data independence, we are going to do the data independence. So this is what a physical level or internal schema. So from this all the levels we can say that a external level or like conceptual level or the physical level. This all the levels are, we can say that levels of abstraction and view of the data. So view level or external level is nothing but what we are seeing on the screen completely. We can access it and we can modify it. But in the secondary conceptual level or logical level, how the data is to be stored and how the data is to be structured actually. So what we are seeing on the data is how it is stored and how it is structured inside of the database. So that is in the second level. And third one, physical level or internal schema. So physical level or internal schema, here what we are how we are storing, where we are storing the data in the local system or drive. So where we are storing in the system. So this is all the levels are implementing for the purpose of data independence. This is all the levels are implementing for the data independence, to achieving the data independence. So this is about data, a view of the data or levels of the data. And the next one is what? Data models. So till now we have seen that different location of the data, a different structure of the data, and what we are seeing on the screen the data. So that is all the levels of abstraction. The data models. So data models are nothing but data models defines how the logical structure of a database is modeled actually. So database, we can create the database, but we can drop the database, we can edit the database, but how the structure of the database is to be modeled actually. How the database structure is to be modeled, how it is modeled actually. So data models are fundamental entities to introduce abstraction in a database. So data models are fundamental entities to introduce abstraction in database. So what we had explained in the previous the previous slides, that so that is what for this purpose. So data models defines how the data is connected to each other and how they are processed and stored inside of the system. So data models tells that how the data is to be connected with each other, and how they are processed depending upon their understanding, how they are processed and how they are stored inside of the system. So that is what we understand from the levels of abstraction, right? So that is what data models, how they are defining and how they are relating to each other. So consider the different types of models. We are having entity relationship model. We are having different types of models: entity relationship model, and object relational model, and object based model, and a semi structured model. We can have four types of models actually. So data models are four types. First one is entity relationship model, and second one is relationship model, relational model, and third one is object based model, and fourth one is semi structured model. So to design the database, we can utilize this all the models. We can utilize this all the models. So first one is what? Entity relationship model. Entity relationship model. So entity relationship model is based on the notion of real world entities and relationships among them. So real world entities, we have to define the real world entities and relationship among that all the entities. Relationships among that all the entities. So while formulating a real world scenario into the database model, the ER model creates an entity set. This is what we have to understand very carefully. So ER model creates an entity set, a relationship set, and general attributes and constraints. General attributes and constraints. So ER model contains entity set as well as relationship set as well as attributes and constraints and constraints. So ER model is best used for the conceptual design of a database. ER model is best used for the conceptual design of a database. So how you are going to be design design at the level, so that is conceptual design of the database. So ER model is based on what? Based on what? Entities and their attributes. It is designed based on the entities as well as attributes. So relationships among entities also. So this is what we understand from the entity relationship model. So see here the exactly example. So this is what entities. This is what entity. We can we already said that the entities can have a relationship. Entities can have a relationship with the help of relationship type, and these all the attributes. These are all the attributes. Suppose you can say that a student is an entity. Student is an entity. Contains student name, contains student age, contains student ID, and contains student location. So this student is acting as a entity, and this name, location, ID, and age. These are all said that attributes. These are all said that attributes. Attributes and entities can have the relationships. Can have the relationships. So then it is said to be ER model or entity relationship model. So entity is nothing but what? Entity in an ER model is a real world object. You can say that real world object having some properties called attributes. Properties say that attributes. And every attribute is defined by its set of values called domain. It's a set of values called domain. So for example, in school database, the student is considered as an entity. So this is what we example here. Student as a student considered as an entity, and a student has various attributes like name, age, class, etc. So student is acting as an entity, and a student contains name, age, location, and class, and these are all the attributes. These are all the attributes. So relationship is nothing but what? So logical association among entities is called a relationship. So to maintain the relationship between two entities or entities with attributes, two entities are two entities with attributes, we must mention one logical association. That logical association is called as a relationship. That logical association is called as relationship. So relationships are mapped with entities in various ways. Relationships are mapped with entities in various ways. So that is what I told, that relationships have different types. Relationships have different types. So that are mapped with entities in various ways mean different types of relationships we are mentioned. So mapping coordinators defines the number of association between two entities. Number of association between two entities. So that mapping coordinators are one-to-one relationship, one-to-many relationship, many-to-one relationship, and many-to-many relationship. So these are all the various ways that maintain or mapping the relationship between entities as well as entities and the attributes itself. Entities and the attributes. So this is what ER model, ER diagrams, ER diagrams. And second one is what relational model. Relational model. So the most popular data model in DBMS is the relational model. So it is more scientific model than others. It is more scientific model than others. So in this we are saying that two types of data or two types of tables. One table can relate with another table. One table can relate with another table, or one attribute can relate with another attribute. One attribute can relate with another attribute. So this model is based on the first order predicate logic and defines a table as an n-array relation. N-array relation. And in this, whatever the values we are seeing on the screen is completely, we can say that tuples. We can say that tuples. So relational model contains tuples as well as attributes. Tuples as well as attributes. So this aside student ID, student name, student age, student class, student section is all called as attributes. Attributes of a student. Attributes of student. And this values whatever seeing on the screen 1101 Alex 149 AA section. So this is all what we call it as tuples. We call it as tuples. So the table contains the relationship with the tuples to the attributes. So tuples with the attributes. So tuples with the attributes maintaining the relationship. So that's why you can say that relational model. This is a relational model. So each and every tuple can have a relationship with the attributes. Each and every tuple can have a relationship with the attribute, as well as the tables contains the relationship with one to another also. One to another also. This is what from a relational model. And next, the main highlights of this model is what the data is stored in the tables called relations. Data are stored in the tables. So tables in the tables, whatever the data is stored is called as relationship, and relations can be normalized. Relations can be normalized. That is nothing but we can simply modify it. We can simply access it, and we can simplify it also. So in normalized relations, values saved are atomic values. That atomic values are nothing but unique values. Atomic values are nothing but unique values and single values. So in normalized relations, values saved are atomic values or single values. And each row in relation contains a unique value. Each row in a relation. So whatever the values in the each row in a relation contains a unique value. A single value or unique value. Unique value. And each column in relation contains values from same domain. Same domain is nothing but same attribute. So each column in a relation contains values from each attributes itself. Each attributes itself. So each and every rows contains unique values. Each and every rows can be normalized, and each and every rows can be contains the same attribute, and each and every data in the table called as relations, and each and every values in the table contain tuples. So this is all what we understand from this relational model. This is all what we understand from relational model. And third one is what object based data model. Object based data model. So the name itself, we are creating one object like student. One object, we can create object like student, and for this object we are creating some attributes. So for this object we are creating some attributes like student name, student age, student ID, student section. So all these attributes belongs to student object. So we can say that an extension of the ER model with notions of functions, encapsulation, and object identity as well. So in this each and every object what we created for the attributes is contain one identity as well as the other values. Identity as well as and other values. So this model supports a rich type of system that includes structured and collection types. So that model supports each and every structured format as well as collection type. So this entity, that what student is an entity and student is acting like a object in this object based data model. And this object contains what? A student name, student age, student id and student section as an entities belongs to this object, belongs to this student object. So this is what we understand from this object based data model. So in 1980s, various database systems following this object oriented approach were developed here. The objects are nothing but the data carrying its properties. So object is nothing but what? The data carrying its through its properties. The data carrying through its properties. Suppose a student contain name is one data, and for that data carrying we have to create one attribute like student name. And the student age also. Student age is also having some values carried by student age attribute. And the student id data also carried by student id attribute. And the student section attribute is also carried all the data of sections data. So this is all what we understand from object based data model. And last one is semi structured data model. Semi structured data model. So structured, semi-structured is nothing but we can elapse the data, we can elapse the data or we can hide the data. And if you want to see the complete structure of the data, we can able to see this. If you are not able to see complete structure of the data, we can hide the levels of the data. So see, this type of data model is different from the other three data models, because we are going to show the structure of data in partial structured or semi-structured way. So the semi-structured data model allows the data specifications at places. So from this point of view to this point of view, from this place to this place, we are going to see the structure, see the data. So remaining all the places of the data is to be hidden. So that is nothing but data specifications and the places where the individual data items of the same type may have a different attribute sets. So different attribute sets can have a different same types of the values. We can hide them and we can able to see them. So for the example, extensible markup language is an XML is widely used for representing the semi-structured data. So for the XML, we are going to form like a tree structure, and we can able to see the complete structure. We can able to see the semi-structure. If you want to see the complete structure, we can open this all the structure elements, and if you want to see the semi-structure, then we can close some semi-structure elements. So all the XML was initially designed for including the markup information to the text document. And it gains importance because of its application in the exchange of the data. Exchange of the data. So semi-structured data model tells that the data completely is not going to show on the screen. If based on the semi-structured elements, we can show the data which is useful to the user, and it is represented with the specification places. Where you want to see the place, where you want to see the data, and where you want to hide the data, as well as where you want to hide the data. So this is all about a semi-structured data model. So totally there are 4 data models. So based on these models only, a database is going to be designed and developed by the developers. So without these models, the database software is not developed or not designed actually, because the models represents the database to how the data is to be stored. The data models represents that the database, how the data is to be stored inside of the database software. So for this purpose, we have to understand this all the data models. Understand? So this is all the data models. So in this session, what we have discussed, we see. So view of the data. First of all, view of the data. So there is nothing but levels of the data also. View of the data, levels of the data. So there are 3 types of levels are there. So one is physical level or internal schema, second one is conceptual level or logical schema, and third one is view level or external schema. So view level or external schema tells that from this diagram, view level or external schema tells that so the data what we are seeing on the screen, what we are getting on this data. So user has to access the data, user has to modify the data. And conceptual level or logical schema, conceptual level or logical schema, so how the data is to be stored, actually how the data is to be stored, and where the data is to be structured, how the data is to be stored, actually how the data is to be structured. And physical level, and physical level where the data is to be actually stored, where the data is to be actually physically stored. So this is all what from we learn from view level or external schema, conceptual level or logical schema, and physical level or internal schema. And about this, we have to uh, we have to discuss these data models. So data models are nothing but used to design the database. Used to design the database. It is a logical structure of a database is modeled, actually. So we can have a different types of relationship models. We can have different types of models. Entity relationship model. Then next relational model. Then next object based model, and the next semi structured model. So four types of models. So each and every model can have a different ways. So entity relationship model can have entities and relationships as well as attributes, but relational model contains attributes and relationships like tuples. And object based model contains objects and entities, objects and attributes, actually. And last, semi-structured model can shows the structure of the data, semi-structure of the data. So this is all what we learned from this session about the levels of abstraction and data models. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.